My name is John Greenland. I am Product Manager for Polyspace Test at MathWorks. We will be doing a Polyspace Test overview and demo. To provide a little bit of context, we'll go over the Polyspace suite of static and dynamic tools. We have Code Prover for runtime error checking. We have Polyspace Bug Finder for standards compliance and metrics. We have Polyspace Test for test authoring and dynamic analysis and code coverage. And we have Polyspace Access for web-based review and collaboration. More specifically, Polyspace Test is our unit testing, integration testing, and requirements testing tool and includes coverage for C and C++, provides unit test infrastructure with our XUnit framework, our link to requirements throughout the development lifecycle, coverage up to MCDC level for safety critical and security critical applications, time and memory profiling based on target resources, graphical test authoring and test case generation, and all of these features are available through our Python API. So this is our Polyspace platform. Let me point out a few different areas of the platform. You'll see on the left here we have our project pane, and we can see the source files that we're operating with. You can see across the top that we have our menu bar, and in this menu bar we have the capability of adding source files, parsing the code, and running tools like Bug Finder and Code Prover on this code. In this case, we've actually run a Bug Finder analysis, and we can jump into that analysis, and we'll see a results dashboard of that Bug Finder analysis. And in this case, we have 3 open issues, so we can click on those open issues. And what we see is a set of defects, and we can click on those defects and it'll actually show us where in the source code this defect occurred. So we have a dead code analysis here on line 24. If we click on the middle defect, we see a dead code analysis on line 19. And if we see the top defect, we see a divide by 0 at line 29. So what we can do with this analysis is we can actually go back to our results, right-click, and we can actually create a test case that brings up a runtime error for that particular defect. In this case, we are generating a test case for that divide by 0, which we've now generated that test case. We can go back to our project. Once we look at our project, we'll see we actually have a Bug Finder test case. So if we click on that test case, we'll see a description of that test case. And this is a test case that should bring up this assessment for a divide by 0 error. And we can right-click on that test case to actually build this test. And this test will be built with code coverage as well. This will actually generate an executable on the host that should be able to show us this divide by 0 error. We can right-click on this test case and say Run Test. And we'll see that this test actually ran and it failed, but we expected it to fail. So let's go look at the results of that failure. We'll double-click on the results. We'll see we have one test that failed. We'll click on that test. We'll actually see that this is the Bug Finder test that we just ran. We'll click on that assessment, and we see, yes, we actually did get a failed assessment. If we click on that assessment, we'll actually see where in the source code that divide by 0 happened. So this is a nice integration between the static and dynamic analysis parts of the tool. So the static analysis is actually feeding information to the dynamic analysis to create that test. Finally, we did generate code coverage for this example. We can click on that, and you can see if we break this down, we can see the different conditions in our source code and the coverage metrics that are associated with those conditions. We also have the function and decision metrics below in this table down below here. And on the right, we have a source code pane that shows us an interactive view of the coverage. So we can see where the red areas where the coverage is, the statements are not covered. We also have the yellow areas where we're looking at the conditions and coverage on the actual conditions, whether they were covered in the true case or false case. And you can dig in here a little more to see whether the particular statements are covered or not covered and why because of the particular condition. Overall, this is showing us the complete coverage of the execution of the program. And this is a good overview of both our test results and our coverage results for the Polyspace Test tool. If you want more information, you can go to the Polyspace Test product page at mathworks.com. Thank you for watching.